Hi friends, so today we have to solve the problem regarding that chair and group. Okay, so in our problem, you know that the first thing that we have to know is the chair number. So first what we do is we will give a chair number, right? So chair number. Okay, so this column is for representing chair number. The second one is for the group name. Okay, so the chair number can be any number, right? So we'll give it as 1, 2, etc. I'll give you up to 200. Okay, so there are 200. Let there be 200 chairs. And group name is like A, then B, C, D, E. Likewise, it will get repeated, right? So we will repeat like this. Okay, so A, B, C, D, E. Okay, so this is our group name. Now, uh, first of all, what the question is like that, if you are giving a number, let it be 125, let it be a number like 125, chair number is 125. You have to understand the student belongs to which group. Okay, so we'll go for 125. Here is 125, and we know that the student belongs to group E, right? If you go to another number, let it be 175. So 175, again the group number is E. Okay, one, two, no, two. Let it be 37. So if I go for 37, the group is B. I hope it is clear. So this is how you have to write the program. Okay, so this is the purpose of your program. So when a chair number is given, you have to identify the group. Okay, now let's go through this problem. Okay, just we'll analyze the output first. Look here. The first number is A, second B, C, D, E. So how many values are there? There are actually five different values, right? So the first value is 1. So this, let it be this 1, 2, 3, 4, 5. So there are five different values. These five different values gets repeated again and again, right? So this five values get repeated again and again. 1, 2, 3, 4, 5. Okay. Now, I have already told you about an operator called modulus operator. Modulus operator. What is the function of that operation? Actually, the function of this operation is to give the remainder when a number is divided by another number. Okay, when a number is divided by another number, it will give you the output, the remainder. Okay, so that's for this modulus operator is for. Okay, now if I give some operation like mod. Okay, if I give 5 mod 2, so 5 mod 2, what will be the output? The 5 mod 2 will be 1, right? The output will be 1. The output will be 1. 5 mod 2 will be 1. If I write 6 mod 2, what will be the output? The output or the remainder will be 0. If I go for 7 mod 2, if I write 7 mod 2, what will be the output? The output will be 1, right? So, what you have to understand is, if you are using mode 2, if I using mode 2, you will get the values 0 to 1, that is 0 and 1 as the output if you are using modulus operator mode 2. Likewise, if I am using mode 3, if I am using mode 3, if I am dividing by 3, what all are the possible remainders? 0 if it is divisible by 3, else it can be 1 or 2, right? So if I'm giving mode 3, so it is not 3 mode, it's mode 3. If I'm giving mode 3, the output can be, or the result, if I do an operation mode 3, if I do the operation mode 3, sorry, it's getting turned by itself. Okay, so whatever the value be, if I'm using mode 3, I do the operation mode 3, the output will be 0, 1 or 2. Okay, here how many outputs are there? five outputs are there. Five outputs are there, right? So there are five outputs. Okay, so if I start it here as 0, 0, 1, 2, 3, 4. So how many outputs are there? Four outputs, five outputs are there, right? To get that output, I can just give it as how many outputs? Five outputs. So I can use mode 5. Mode 5 can be used. So if I use mode 5, the output can be 0 or 1, 2, 3, 4. So these are the five outputs. If I using mode 5, the five outputs will be 0, 1, 2, 3, 4, 5. I hope it is clear. Okay. Now, okay, you all know that this A is a character. You all know that this A is a character, right? So it do have an ASCII value. The ASCII value corresponding to A is 65, right? The ASCII value that is corresponding to B is 66. The ASCII value corresponding to C is 67. The ASCII value corresponds to D is 68. And the ASCII value that is corresponding to E is 69. Okay, so the ASCII values corresponding to A is 65, ASCII value corresponding to B is 66, ASCII value corresponding to C is 67, the ASCII value corresponding to D is 68, and the ASCII value corresponding to E is 69. I hope it is clear. Okay, now I'm gonna write this in a series. Okay, 65, 65 can be termed as 65 plus 0, right? 65 can be termed as 65 plus 0. Clear. 66 can be termed as 65 plus 1. I hope it is clear. Okay, 66 can be termed as 65 plus 1. 67 can be termed as 65 plus 2. 68 can be termed as 65 plus 3. And 69 can be termed as 65 plus 4. Okay, so if you are finding 65 plus 0, okay, 65 plus 0, you will get 65, right? 65 plus 1, you will get 66. 65 plus 2, you will get 67. 65 plus 3, you will get 68. 65 plus 4, you will get 69. Okay, so 65 is constant here, right? You have to identify whether you have to add 0, 1, 2, 3 or 4. You have to identify whether you have to use 0, 1, 2, 3 or 4. I hope it is clear. So by checking the input number, if you can identify whether you have to add 0, 1, 2, 3 or 4, you can identify, you will get the ASCII code of the number, code of the character, so that you also get the character. So what you have to do is, I am simplifying the problem. What you have to do is, if I take a number, you have to identify whether which number to be added with the 65. 0, 1, 2, 3, 4 or 4. Which number has to be added with the 65 to get the corresponding character. Okay. Now we will check on the input. So we will now check on the input. Okay. So you know that there are five combinations. So I will be using mode 5. So here I will be using the function mode 5. There are five combinations. Okay. What is the one value of 1 mod 5? 1 mod 5 is 1, right? 1 mod 2 mod 5 is 2, 3 mod 5 is 3, 4 mod 5 is 4, 5 mod 5 is 0. Okay, so if I use mod 5 operation here, mod 5 directly to the input value here. Okay, so if I'm using mod 5 and mod 5 input value mod 5, if I'm using input value mod 5, what I'll be getting is 1 2 3 4 5. But here you are not supposed to add 1 2 3 4 and 0. Instead you have to add 0 1 2 3 4. So instead of adding 1 2 3 4 0, you have to add 0 1 2 3 4. Okay, so just a small rearrangement is required here, right? Instead of adding 1 2 3 4 0, you have to add 0 1 2 3 4. Okay, so what do you have to do? You have to make this as 1. Okay, you have to make this as 1. Sorry, this as 0, this as 1, this as 2, this as 3, and this as 4. Okay, so what I do is, first of all, for easy, I do like this, that is input value mode 5, and I am subtracting 1 from that. I'm subtracting 1 from input value mode 5. Let's check what happens. Input value mode 5 minus 1. Okay, input value mode 5 minus 1. So if I write input value mode 5 minus 1, that is 1 minus 1, that is 0. Yeah, you got 0. Okay, next is 2 minus 1. 2 minus 1 is 1. Right? Next is 3 minus 1. 3 minus 1 is 2. Yeah, correct, right? The same order, 0, 1, 2. Now next is 4. So 4 minus 1 is 3. That is also correct. 0, 1, 2, 3. But the next one, what happens is, here it is 0. But if I write 0 minus 1, the value will be minus 1. Right? If I write 0 minus 1, the value will be minus 1, which is not correct. Here instead of that, I need to get 4. So what should I do? So I have to make another change. Okay. So for that, likewise, if you do something like a trial and error method, okay, look here. Instead of input mode 5 minus 1, I am writing input minus 1, input minus 1 mode 5. Input minus 1 mode 5. If I am writing like this, what will happen? If I write input minus 1 mode 5. So if I write input minus 1, what is the input? 1. 1 minus 1, 0. 0 mod 5 is 0. Next is 2 minus 1 is 1. 1 mod 5 is 1. Next is 3 minus 1 is 2. 2 mod 5 is 2. Next is 4 minus 1 is 3. 3 mod 5 is 3. Next is 5 minus 1 is 4. 4 mod 5 is 4. Clear? So the equation that I will be using is input minus 1 mod 5. Okay, so input minus 1 mod 5. If I add this to 65, if I add this to 65, okay, if I add this to 65, what I will get? I will get the ASCII code of the group name. Okay, so that I will be doing. So I'll be taking the compiler. Okay, so I'll be taking the compiler. Just check it out. Okay, so I'll be taking an online compiler. Let it be like this. So okay, so this is a online compiler that I'm taking. Okay, so I'll be using one integer, so I'll be writing int a. I'll be using a character value, so I'm writing char b. Okay, anyway, I need to get a chair number from the user, right? So I'll be writing printf and the chair number. So this message will be shown to the user, and I have to read the value. So scanf mode d, it will be address of a. So I'll be storing the chair number in a. So what I will to get for getting b, or for getting the value in b, I'll be doing 65 plus a minus 1 mod 5. Okay, 65 plus a minus 1 mod 5. I hope it is clear. Now I'll be displaying the resultant value printer. The group number is, I'll be giving mod C. Group name is, okay, group name is, sorry, I'll give the capital. Okay, so the group name is mod C, and I will be printing the value in B. I hope it is clear. Okay, so this is the program. If I run this, I'm sorry, I haven't given a semicolon here. Okay, I hope it is clear now. Okay, so enter the chair number. So what is the chair number? Let's look on the page. Okay, I'll be taking the chair number as, so I'll be hiding this. Okay, I'll be hiding this. So I'll be taking the chair number for 122. 122, the answer should be B. So I'll be giving 122, and the answer is, oh God, I'm not getting answer. I hope there is some mistake with the compiler. So I give 122. I'm not getting an output. Yeah, now it's, now we are getting the output. Okay, there was some problem in the compiler. So the group name is B. Again, if I run this and I give another number, let the number be 139. So if I am giving 139, and the group name is D, here you can see that 139 is D. Likewise, if I go for 163, so if I go for, again I am running this and I go for 163, the group name is C. Okay, 163 is C. Clear. So this is how you will be writing the program. So if you doesn't understand any part of this program, you please feel free to contact me. Okay, thank you.